Hi everyone, welcome back to the video where we were discussing space complexity and we were solving some of the questions related to it. In our last example, if I am not wrong, we discussed that how to calculate space complexity of any recursive algorithm, where we mentioned one important point that recursive call stack space also counts for the space complexity, and we also concluded that it does not means when there is an n calls it will take O of n space. So taking that as an input to this video, let's have one example on it where we will be showing that it doesn't mean that if you have n calls so it will have O of n space. So let's take one example. Int add sequence. Alright, I'm writing it as a formal algorithm. So defining sum as 0 for int I equal to 0, I less than n, I plus plus, then your sum will be, let's say, sum plus pair sum I comma I plus 1, and I'll just return this sum. Okay, now what I'll do is I'll write this function pair sum int x comma int y, then I'll return x plus y this. So let's say this is an algorithm, a basic algorithm, right? So I have to calculate now space complexity. Now according to you, if we go with the very basic, you say this is constant 1 unit, this is constant 2nd unit, this is constant 3rd unit. All right, anything else we can see? Yeah, x and y, 1 1. So how many constant? 1 2 3 4, 1 2 3 4 5. So we will say that s of program is nothing but c plus sp. So we will say 5 constant space, and you will say this particular thing will go for n times, so you will write 5 plus n, or dependent on how many times you want to execute it. If it is this, so it becomes O of n according to you, which is wrong. That's why I made you write that you should not think as a thumb rule that whenever n calls is happening it means O of n space. Now if you see that there will be here, if you see this, right, there will be around O of n calls for this pair sum for sure, right? But those call does not exist simultaneously on the call stack. Are you understanding it? In our previous example where we were just writing add of 4, we need simultaneously this add 3, then add 2, and then add. But if you understand this, right, this pair sum, the call does not exist simultaneously on the call stack. So basically this has no dependency. No dependency. No, it has dependency, but in case if this with pair sum, right, when it does not simultaneously go, you don't, it act as a constant unit. It act as a constant unit, right? So therefore what is the s of p is equals to c plus s of p, which means that s of p is equals to 6, which is nothing but constant, which is nothing but O of 1. So that's why I made you write that if any of the algorithm of n call doesn't mean that it will take O of n space, right? Because if you go here, the first time you go here, you go this call and then you make this call, right? So you go first here and then you make this call, right? So that's why it simultaneously doesn't happen. It is not like that here itself you are calling it, right? Here itself you are calculating and allocating the space to it. So compiler doesn't work that way, right? So if functions are not called simultaneously, that space won't be counted in the space complexity. Understanding it? All right. So we'll conclude this example, and in our next video, we'll see uh, space complexity of some of our popular algorithms, and we'll try to establish a fundamental rule when we say O of 1 or O of n space complexity exist. So how we can conclude that these things will happen. So it's a very basic fundamental rule, I say, which helps me to calculate the space complexity that we are going to see it. So if you are new to the channel, please like, share and subscribe it. Thank you.